Okay, welcome. Today you're going to be watching the first set of videos through a series of videos for Chapter 2. Today we're going to be talking about 2.1, combining like terms. Okay, so let's just talk about terms in general. So if I talk about terms in general, so let's define what a term is. So a term is a number or variable or numbers and variables multiplied together. So you've seen this before, we discussed it last class. So an example of a term could be just a number, right? Like 4 or the number 1, right? Or it could be a bunch of variables, right? X, Y. Okay? Now, or it could be a set of numbers and variables multiplied together like we see 2x or 4y. Stuff of that nature. Okay? Good. Now let's talk about what are like terms. Okay, what are like terms? Like terms are terms that are in the same family. So if I talk about terms, and then let's give an example of um, 2x. All right, 2x. Well, let's break it up. Okay, I want to talk about like a first name and a last name. So this number in front, we are going to say that is this term's first name. Okay? Now we're going to say that the X is his last name also. Okay. So, like I say, if you're, having Thanksgiving dinner or you go to a birthday party or something of that nature, you're only going to go to somebody's, house for a birthday party in your family if their last name is Green, right? But you wouldn't go to that house if their last name was Greenberg, right? Because they're not in the same family. It might look the same, okay, but they're not the same family. So in this case, I have 2x. His first name's 2, his last name's x. So his last name is just x. So technically, if I was just going to list a bunch of like terms for 2x, I could say that, okay, well, I have anything that ends in x. So I could say 4x, 1x, negative 5x, negative 44x. Really doesn't matter, but as long that it ends in x. Let's give one more example. So let's say I had, I don't know, let's just go with x squared. Okay, x squared. So his first name, what is his first name? It's actually invisible 1, right? So his first name is 1, his last name is x squared. So a like term to x squared will be anything that ends in x squared. So it would be, let's say, I don't know, 2x squared, 3x squared, 4x squared, and so on and so forth. Anything that ends in x squared, so it doesn't matter. Okay? So today we're going to be talking about combining like terms, so we have to group them together. Okay, so let's look at number 1. I'm going to highlight. You could grab colored pencils or you could grab highlighters, whatever you want to do. So I'm just going to color code like terms. So here I have 2x minus 5, sorry, 2x squared minus 5x squared. So let me highlight that x squared, right? That whole term of 2x squared. Now where is there another x squared? Okay, well I see an x squared right there and I have to combine the coefficient in front. So here I could see that both of them belong in the same family. So now all you are going to do, you know that it's going to end in something x squared. But what x squared? Now all you're going to do is add or subtract the coefficients. That's the number that's in front. So here I have 2 minus 5. What's 2 minus 5? It is negative 3. And that's my answer. Simple as that. Okay? Good. Let's try number 2. Okay, good. Now I'm going to say, okay, I'm going to color, in my case, I'm going to color all the z squareds. That's the family here. In that case, I have 8 z squares. And I'm going to say, okay, where do I see another z squared? Right there. I'm going to color the number in front. Good. Now I come to the plus 7x, right? Is that in the z-squared family? No. So I'm going to color that a different color. I'm going to color that blue shade. Okay, good. So now I want to combine what the same colors are. Remember that we want to combine like we did with the starburst and the activity. So the z-squared isn't going to change, right? The color isn't going to change. It's still going to be z-squared, but how many z-squares? Look at the coefficients. I have 8 minus 2, which makes 6. Okay, good. Now, can I combine 7x with anything? No. So all I'm going to do is add it. Okay? Now, this is called an expression. Okay? So most of your answers are going to be expressions. So an expression, I'll get into that in a future lesson, but an expression is just a group of terms that are added or subtracted together. Okay, awesome. Now let's try number 3, get some more practice. And we are going to go highlight. Okay, now I have, let's color -2, right? Now -2 is unique. What's his first name? Well, the last name we all saw are variables, right? X squared, z squared, x. Well, he doesn't have a last name. So in this case, his last name is blank, but his first name is -2. So this is called a numerical term because it's just a number. So we understand that we could just add and subtract all types of numbers, right? So good. So that's going to be in the number family. Now let's say we have a C here. So let's go 3C. We're going to color that color. And we have another C. So we're going to color that with the number that's in front. Good. So now let's combine let's combine what's the same color. So I have this purple color. So now I have something C. All right. Now I'm just going to add or subtract the first coefficient numbers. Here I have 3 minus 4. 3 minus 4 is -1. Okay, good. Now, do I have any numbers to combine? I do not. So all I'm going to do is bring down that -2. And look at that. That's my answer. All right. So this is just a couple examples of combining like terms. Okay, now you're going to have 2 money problems. Okay, these are both money problems. So you're going to try them on your own. Now, remember, for number 5, you're going to have an extra step. To get rid of the parentheses, think distributive property. Okay? So good luck. Go through these 2 examples, get them checked, and you'll move on to your midpoint check.